In this video, we're going to look at some more examples of the fundamental theorem of calculus. So what we have is integral from 1 to 2, 2x to the 1/3 plus x to the 1/2 divided by x, integrated with respect to x. The first thing we'll do is we'll simplify the integrand. So we have integral from 1 to 2, 2x to the 1/3 divided by x to the 1 plus x to the 1/2 divided by x to the 1 dx. We get integral from 1 to 2, 2x to the 1/3 minus 1. We have the same base. We subtract off the exponents. That's going to give us negative 2/3 plus x to the 1/2 minus 1, negative 1/2. Now we'll reverse the power rule, integrate term by term. We're going to get 2x to the negative 2/3 plus 3 over 3. That's going to be 1/3 divide by 1/3 plus integral of x to the negative 1/2. Add 1 to the exponent and divide by the same number. We get x to the 1/2 divide by 1/2 evaluated from 1 to 2. We just applied the fundamental theorem of calculus. Let's simplify further. We get 6x to the 1/3 plus 2x to the 1/2 evaluated from 1 to 2. Let's put the upper limit in. We get 6 times 2 to the 1/3 plus 2 times 2 to the 1/2 minus, plug in 1, we get 6 times 1 to the 1/3 plus 2 times 1 to the 1/2. So simplifying further, we get 6 third root of 2 plus 2 root 2 minus, and here we get 6 plus 2, that's just 8. The answer is 6 third root of 2 plus 2 root 2 minus 8. This is the value of the definite integral. All right, let's look at another example. Here we have integral from 0 to 1/2, 1 over root 1 minus x squared dx. So what is the antiderivative of 1 over root 1 minus x squared? What is the function whose derivative gives us 1 over root of 1 minus x squared? That is clearly arcsine, sine minus 1 of x, evaluated from 0 to 1/2. That's going to be sine minus 1 of 1/2 minus sine minus 1 of 0. How do we find arcsine of 1/2? That is saying find the angle whose sine is a half. From the diagram, we can clearly see that sine of pi over 6 is opposite over hypotenuse. Sine of pi over 6 is 1/2. So arcsine of 1/2 is just going to be pi over 6. Sine minus 1 of 0 is 0. So the answer is pi over 6. This is the value of the definite integral. Namely the integral from 0 to 1/2, 1 over root 1 minus x squared dx. It's also the shaded area that we have in this diagram. The area from 0 to 1/2 under the curve y equals 1 over root 1 minus x squared. All right, let's look at another example. Here we have some computation, and we want to know why this is a wrong computation. So we have integral from negative 2 to 1, 1 over x to the 4th dx, and we rewrite this as x to the minus 4, integral x to the minus 4 dx. Reversing the power rule gives us x to the minus 3 divided by minus 3, evaluated from minus 2 to the 1. So now putting the upper limit in, we get negative 1/3 times 1 over 1 cubed minus 1 over minus 2 cubed. When it's all simplified, we get negative 3 over 8. Why is this the wrong answer? Well, the reason is that f of x is equal to 1 over x to the 4th is always larger than 0 for all x. That means the integral from minus 2 to 1, 1 over x to the 4th dx, this integral will represent the area under the curve, and that has to be positive. But we have a negative result, so that means something is wrong. So the reason is FTC, fundamental theorem of calculus, cannot be applied to a function that's discontinuous, and this function clearly is discontinuous at x equals 0. So FTC can only be applied to continuous functions. Let's illustrate with a diagram. So you can see that the graph of 1 over x to the 4th has a vertical asymptote at x equals 0. Namely, the limit as x approaches 0, 1 over x to the 4th is infinity. So this function is discontinuous at x equals 0. We can't apply the fundamental theorem of calculus. All right, thanks.